Welcome back to Curiosity Theory. It is your co-host, Dr. Dakotah Tyler, Dr. Star Kid on all platforms. I'm an astrophysicist, a physics professor, a soon-to-be published author, and just a great guy, honestly.
Yeah, well, we'll see about that. My name is Justin Shaifer. Some people call me Mr. Fascinate. I'm a STEM media producer, science communicator, and overall fan of nerdy stuff. And we have a very special guest who is completely riveting, that's going to tell us about a lot of interesting neuroscience, the implications of free will, and some of her research on pain. We have Lindsay Ejoh. You want to tell us a little bit about yourself, Lindsay?
Hey everyone, my name is Lindsay Ejoh, at neuro_melody on social media platforms, and I am a final year PhD student in neuroscience at the University of Pennsylvania. Woo woo, almost there, almost graduated. I'm about to say Dr. Ejoh very, very soon. So,
Period.
um, and my research focuses on the neuroscience and neurobiology of pain and pain relief, with a special interest in pain relief from opioids. Yeah, I'm excited to get started today and chat with you all about my research and about the brain in general.
All right, let's get into it.
Right now. Give me one more chance.
Almost there, Lindsay.
Oh, good. I'm admiring your setup now that I've
It looks good, right?
Does it look crystal clear on your side?
Nah, Justin got this place rocking in like a month. Basically, this went from empty to everything that you see here. And what you can't see, obviously, is the cameras. So there's 3 like cinema cameras set up, and then we got a couple studio lights and a monitor, and then there's a couple computers and editing stations over here. It's pretty crazy. Like this is like a legit high level production studio.
That's
impressive.
Yeah, Lindsay, I think I was telling you a little bit. Like I started out in science media production, so I I do a lot of SciComm work as well. But I made shows for like PBS and Discovery Channel, and so yeah, kind of from top to bottom, I learned the process. And I own a studio, or I used to own a studio in Los Angeles, but the bills were way too high and didn't make sense. So I'm like, you know what? Let's not do that. So yeah, scale things down, and now we can basically do this forever.
Perfect.
So
did you move to Austin, or are you guys just going to Austin to record?
Oh no, this is Tulsa. This is Tulsa, Oklahoma.
Not Austin. Okay.
Yeah, but I mean, so technically, I have a bed. It's a 2-bedroom, so I actually have a place to sleep in here. Dakotah also has a place to crash in here when he needs to.
Oh, great.
Yeah, he made me sleep in the bathtub.
Yeah, Dakotah's in the
Give me a
bathtub,
comforter.
but it's all good. You know, I think he's comfortable there. You know,
he got like a pull-out couch, and when I got here, he was like, "Yo, you ever seen one of these before?" I'm like, "Yeah, bro, I've seen a pull-out couch before."
Man, I was impressed with the design of this specific one, but
it is cool. It's it's like a niche pull-out. It's like unfoldable.
A niche one, yeah.
A niche, yeah.
But yeah, Lindsay, we appreciate you jumping on with us and rapping with us. And we are so excited to hear about your perspective on some incredible work that you're doing. The last time that we had a conversation with you, you were in the middle of a brain surgery, right, with a mouse, and you were still able to have a coherent conversation with us. And it sounds like you didn't make any mistakes in the surgery as well.
Yeah.
I hear. I mean, to be fair, I was at the end of the surgery, so it was just like the suturing at the end, which is pretty methodical. But I find that once you've done them for so long, because the surgeries, I mean, I'm not going to call it simple because it's a brain surgery, but once you like learn all the steps, it's like kind of just, ABC and then wrap it up. Make sure you follow all the instructions and everything. So anyway, I was like pretty close to ending, so I was able to do both.
Yeah, and how long were you actually doing surgeries? Like, how long have you been doing surgeries on mice like this?
So I started doing these like brain injection surgeries in my first year of grad school, but actually when I was in undergrad, in my 4th year, I was in a lab that studied the gut. So I would do some viral injection surgeries into the gut as well back then.
Yeah, I remember I hopped on the call. We were just doing like a discovery call for anybody listening to talk with Lindsay a little bit. And I think I hopped on a few minutes late, and I came and I just saw you were like at the microscope. You had your hands in the gloves, and I was like, "Oh, like what's going on? Is everything cool?" And Justin was like, "Yeah, she's just doing surgery on a brain. It was pretty funny. And I was super impressed that you were able to do that and talk to us. I don't think I could be doing research and having a serious conversation.
Even if it was the sutures, man. Yeah, I was also super impressed. But what was the purpose of that brain surgery?
Yeah, so I'm in a lab that studies pain, and we're interested in different brain cells throughout the brain that contribute to the experience and the conscious perception of pain. So what we were doing was injecting a compound that will allow us to turn off cells that are involved in pain to see if that can kind of reduce the experience of pain in mice. So the injection, so the surgery was the first step, which is injecting that compound, which in this case is a virus.
Got you. Okay. Can you tell us more about how that even works, though? So it's like you inject a virus in a mouse's brain in order to understand how it perceives pain?
Yeah, so happy to get more into it. So so we know that viruses, their main goal is to attach to a host and replicate and spread as far as possible, or at least that's what they're evolutionarily tuned to do. So neuroscientists or biologists in general have taken advantage of this by saying, well, what if we want to introduce a new protein or a new gene into a particular cell in your body? How can we do that? Well, we could make a virus do it for us. So what we can do is program or genetically engineer viruses to make particular things in their genome that can actually be expressed, or particular proteins that can be made in that host. So in this case, we want to tell the cell to make a particular protein that we can now use to make that cell turn off. So if we make the virus have that protein in its genome, and then the virus will make that replicate that particular like off protein, then the host cell or the mouse's cell, so it'll make that into the protein, and then it'll make this like off channel or this off compound or receptor protein. And then we now can use that protein that the virus helped the cell make to turn that cell off at will. And in this case, we're doing that to cells that are involved in pain. So
okay, so these are these neurons?
yes. So sometimes they can enter non-neuronal cells just depending on what your virus is tuned to. But in this case, we're looking at neurons only.
Okay, so basically we have neurons in our brain that are responsible for everything that we do as humans. And some of these neurons, if I'm understanding you right, some of these neurons are responsible, moderate, or control the sensation of pain that we have. And what you're doing is you're injecting viruses that you have engineered. Is that right? These have been, okay, so these are viruses that have been engineered that teach some of the cells how to build this on-off switch that you, as you put it, which is a protein. And once you have the virus infect a bunch of neurons and like tack on this on-off switch, maybe you can like modulate the amount of pain that a person is feeling. Or I guess in this case, you're working with mice.
Yeah. So then we can manipulate these cells and change their electrical activity, which can turn them on or off. And if they're important for pain, turning them off will reduce pain behaviors in the animal. So then in a few weeks, what I'm going to do is activate that off switch and see if that reduces the amount of pain animals feel.
Super interesting. So why use a virus for something like that?
So good question. This is all like a form of gene therapy. I don't know if you've heard of gene therapy. This ways that we can change the human genome to kind of solve diseases that are genetic in nature. You can manipulate genes, but through other ways, like for example, through something called lipid nanoparticles. This is what is a huge part of the COVID mRNA vaccine.
Mm-hmm.
So
I don't know what lipid nanoparticles are.
So basically, how do we package the product that we want the cell to make? We can make a virus make that product, or we can just put the gene that we want it to express, put the protein that we want into a little until a tiny bubble, like made
a
of
phospholipid bilayer, right?
Yeah, but like just the lipid part, I guess. I don't know if it's
okay.
a bilayer in this case. I'm not an LNP expert, but you can package particular proteins into these tiny little particles as well. And those can enter the cell, and you can make, in this case, the COVID spike proteins that can help you fight off the virus if you get it. So that's the basis of the mRNA vaccine. But so it's just like it's just one of the many ways that we can manipulate the genome. There's a lot, I would say, in neuroscience, a lot more research in how to do it virally. A lot of times it's like, why do we do it this way? Sometimes the answer is just because that's how we've done it. And we've really, really mastered it, and we've found a way to make it with the least amount of side effects. So that's what we're going to go with. I think that's why we're doing it in our lab. Also, the cool thing about viruses is that you can target them to particular cells. So in this case, I care about cells that are sensitive to opioids. We're not giving any opioid drug, but we're interested in cells that would have been turned off by opioids, which are used to relieve pain. So it's kind of like a workaround way to turn off pain cells and reduce pain without any of the side effects that would have come with giving an opioid drug. So we can program the virus to only enter cells that are opioid sensitive, or you could program it to only enter cells that are pain active, or you could program it to only enter cells that respond to cannabinoids like marijuana or something. It just, whatever you want, you can now tune the system using these like genetic tools to be as specific as possible at the cells that you want to manipulate. So you can know exactly which ones are necessary for the particular behavior you're interested in this case, pain behaviors.
Right. Okay. But so is the virus is changing the DNA of the cell? Is that it's not changing the DNA?
So what the virus is doing is introducing a new gene product that the cell can make into a protein. You still have all the DNA you have. It's just like called gene therapy because you've given it a gene. You're not necessarily like changing your own genes. I don't think we can do that in a living, I don't know, don't quote me, but I don't think you can do that in a person that's like walking around living, even a mouse, without Lindsay, like, causing some harm.
So an accurate metaphor might be like the virus is turning a cell into a factory for these specific types of proteins.
Yes. A cell is already a gene factory. It's one of its main jobs is to turn genes into proteins, and proteins are the things that make your cells do what they do so that you can keep your body alive. So these little mini factories floating all over your body that make up your body, it's targeting particular pieces of that factory to like do a particular thing. So you've now created a way to express what you want. So then you can make a cell turn on, you can make it turn off, you can make it do that long term. You could make it do it only for a little bit. You can make it responsive to light to turn it on and off. So if you stick a laser in there and you turn the light on, those cells will turn off only when that light is on. And that's
called you're like installing a custom kill switch.
Yes. Or you could install a custom hyperactivity switch. So you can make the cells, kill switch and impact.
I got you. Yeah, you can go both ways.
No, that's super interesting, Lindsay. Like I think that's fascinating research. I'm curious about the implications for humans, right? Like it sounds like you're doing this to figure out some specific things about maybe how the human brain works and maybe even new treatments and therapies.
The mouse brain, in this case, we're studying mice, but many of the parts of a mouse brain are also in a human brain, especially the area I'm interested in, like the mouse has a thalamus, we have a thalamus, and they have many of the same, subparts as well, and many of the same cell types.
What does the thalamus do?
The thalamus is like this gateway center for all your senses. So everything you're feeling, most of the things that you feel kind of like sends signals to this one area, which then sends it all over to the brain, kind of like a gateway for all your senses. And then it also, when you're sleeping, shuts down and is a gateway to make sure that you're not experiencing senses while you're asleep as well. So it's this very important area for monitoring what things that are in your environment actually enter your conscious awareness. Mm-hmm. And then we're interested in how it's involved in the experience of pain.
Right. And have there been any emerging findings in any of the previous research done? I know like a lot of stuff that you're doing right now is ongoing.
Yeah, so there is evidence that when you turn cells off in this area, it could relieve pain. Nobody has, like, for example, some people have completely killed these cells. So it's called a lesion, like literally just like give a huge electric shock or something that like kills the cells in that area, and the animals experience less pain. This has also been done in humans as well. So many people with chronic pain, there have been studies of people with chronic pain where if they lesion or kill the cells in this area, their pain can be relieved, at least moderately. So we're interested in that fact, plus the fact that we know that opioids can also shut these cells off. So we know that removing these cells relieves pain. Turning these cells off can relieve pain as well. So what if we can turn the opioid cells off to relieve pain? So it's kind of a way to like really tease out if we can target this opioid sensitive cells to relieve pain. And if we can do that in a mouse, we're not necessarily going to then do brain surgery in a human and manipulate their genome, because again, this research is kind of too early on for that. For example, the surgery to inject the virus is not something that's, how can I say, compatible with a long life. So this is kind of a way to, so it's exploratory. It's like, let's understand how pain is processed in the brain so that in the future, if we were to make this process safer, maybe we could use this to turn off, maybe we could use this to relieve pain, or maybe we can just have a better understanding of how pain is propagated through the brain so that we can have ideas of what areas to target in the future. You know what I mean?
So I'm assuming that, I'm an astrophysicist. I'm not a neuroscientist, so I don't know that much about the brain, but I would assume that a neuron that is responsible for the relationship with pain may also do many other things.
Exactly.
So how do you know, why is it safe to just turn off that cell because we know that it's associated with pain? How do we know that there isn't some other completely unrelated behavior, or maybe just some other emergent process that's happening within the brain that you would be affecting? Or I guess is the exploration sort of trying to see if that is the case or not?
Exactly. So the exploration would answer the questions of what else happens to. So the first step is seeing if it turns off pain. Then the next step is seeing, okay, if we turn these cells off, what else is affected? If you put the animals through memory tests or different like cognitive tests, or they put them in a maze or anything. Does any of that get impacted when you turn these cells off? These are important questions to ask as well. If you ever in any way want to use this as a treatment tool. So this is kind of like a first exploratory step.
Yeah, that's exciting, Lindsay. Like, I've read a lot of stuff about regenerative medicine and kind of the future of medicine. And I think the common complaint among people today is like, like a lot of pharmaceutical companies, they focus on not curing you, but like temporarily treating you for something. And it sounds like this could be an advanced form of maybe like a either surgical intervention or something that's even easier to take to get access into your brain, that allows you to basically turn off the pain response without all the side effects that come with these chemicals that we're putting into our body that, it's kind of hard to measure from person to person.
Yes. So everything unfortunately has side effects because, the process I'm explaining now is not without its side effects as well.
Okay.
So for example, the brain surgery, when you put this needle in there to inject it, the needle punctures it's very, 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 very thin, but it still punctures all the brain matter on its way down. So like whatever is directly above this area in the thalamus is going to get like basically lesioned, which is a huge confound, but it's something that we have to, but like you mentioned, the brain is regenerative. It does rebuild connections all the time. So people with brain injuries, they regain their memory, they regain their functions over time through learning. So, I mean, it's another reason why, like I mentioned, people have completely removed the cells in this area or killed them off. The animals are still able to do other things because the brain just creates all these different workarounds. So it's another huge field to see what workarounds would happen if you were to do this particular treatment or anything like that.
So there is a medical condition, maybe you know about, I mean, I'm assuming that you do since you research pain, where there are some people who don't feel pain. They're like not able to feel pain, right?
Yeah.
And it's like dangerous because they may like break a bone or they may burn themselves and they sort of have no way to know that that's what's going on. Is there anything to learn about with what you're trying to do from people like that and whatever is special or unique about their neurons?
Yeah. So many people with this lack of pain, it's called congenital insensitivity to pain or CIP. Mm-hmm. So it happens from birth for a lot of people. They do not have a particular gene called NaV1.7. This is a protein that powers pain neurons. And the problem is pain sucks and a lot of us don't want to feel it, but it is something that's necessary. Even as I'm sitting up right now, if I didn't have pain receptors, I could be sitting weird. I could be harming my muscles. I mean, as a kid running around, you're going to want to know like when something's broken, if you need to get it treated, or it's this huge, like, even though it's unpleasant, it's this evolutionarily necessary thing.
Yeah, it protects you, right? Like it protects you.
But people have done a lot of studies in NaV 1.7 to understand if we can use that to relieve pain. And there's been a huge push for that. But honestly, the jury is still out. There have been quite a few failed clinical trials, or there was one pain drug that targeted a slightly different protein called NaV 1.8. That had a lot of promise. I've heard, I don't know, I think I have to do a more updated reading, but it did get, I think, FDA approved to be an like acute like surgery pain kind of drug and an alternative to taking opioids. But we don't know if that's going to be effective at all in long term, or if it's even the best option for acute pain right now. There just has to be a lot more studies to show that.
So a person that has CIP, in principle, or maybe like in theory, the type of work that you do, installing proteins to like change the cells effectively, could you do something like that? Inject, obviously you're not doing this to humans yet, but could you inject the brain of a person with CIP and like give them this pain response, like turn that gene on, install whatever protein is required and like flip that on? Or are there pain cells so different that what I'm saying is kind of like too reductive and too simple?
I think that's very promising. I would have to look it up because that's actually really cool. I don't see why not. I don't see why not. So I need to look up if we do a NaV 1.7 like kill switch or knockout throughout the body of a mouse. If we then activate maybe a different pain population or reintroduce pain. Usually people don't go the other way around. So there's like less research and like
trying to increase pain.
Imagine if you turn it up too much and someone's like, ah!
Well, if you've never felt pain before, anything would be like the worst thing. It would be the worst pain that you ever felt.
You technically have no pain tolerance. You never had to have one.
Right. Like taking a step, you would be the most sensation that you had ever felt before.
If that step was painful, because you still felt like touch your whole life. So I think you'd be used to the touch part. Because like touch is sensed by different receptors than pain. So most people have felt touch. So they're not like numb. They just can't feel like when, for example, a deep pressure becomes painful.
Interesting. So, Lindsay, I actually have like two questions that have kind of been on my mind. So, one of them is I always read that scratching was kind of like, or itching, right? The sensation of itching was kind of like a mild pain response, like a mild stimulation of a pain response. So, let me know if that's a myth. And then the second thing is another thing I read about is this idea of heartbreak, right? Like this pain that one might feel after the loss of someone, or things not working out. And then that actually kind of having a physical or physiological response in the brain that's detectable. What do you think about those two things?
Sure. So are you talking about how when you itch, it's a pain relief or it's causing pain?
No, I think it was something I read years ago, and it could just be pseudoscience. But just the sensation of itching is like your neuron, the sensation of pain, just like a really weak pain sensation.
Oh, so pain and itch sometimes can share the same like cells that transfer them, but other times it's separate. So like we think of them as different processes. But for example, we'll give compounds to induce pain in our lab that like also are itchy. So sometimes it can overlap. It just depends.
Yeah, I feel like sometimes when I have like a scab or something, it'll like itch a little bit, and then I'll be scratching it, and then it'll come off. I'm like, dang, I didn't want to do that. You know what I mean? When I get cuts and be outside, that doesn't happen to you.
No,
I guess
I know that they say don't scratch mosquito bites. You can't stop me from scratching a mosquito bite.
Yeah,
that joint is just so bad, and it feels so good to scratch it.
Yeah, well, that's a little strange, man.
But if it's bad for you though, because you can get infected, right?
Yeah.
If you scratch,
Put
then
bacteria in it.
why do I have the natural urge to scratch it? Why have I not evolved to just leave it be? Right? Like, does that make sense what I'm saying?
Yeah, it's like you've evolved to want to attend to this injury on your body. You want to do something to relieve this itch, this negative feeling, and you know that scratching temporarily relieves that itch. And not only does it do that, it also like activates your reward systems and tells you, yes, more of that. So then that might
dopamine I've ever gotten.
It might overpower the subconscious, like this is bad for you, this can make you bleed, this can make the area worse. And it just depends on your own personal like willpower, I guess.
Willpower, yeah. I don't really have to scratch mine, Lindsay. I never really have that thing, like, where, if something itches, I just can control myself.
Yeah, he's like a real stoic, masculine man.
Like a self-control and discipline thing, it's kind of simple even for me. It's rudimentary. I probably like got over that when I was like 5 or 6.
Yeah, bro. Real man.
Yeah. But the heartbreak thing, I'm curious about that too.
Sorry, the second one was what again?
The heartbreak thing. So yeah, like is there like a physiological indicator in the brain for something like heartbreak that's similar to pain?
I mean, that question is pretty layered. Heartbreak is very stressful, and stress can make your pain worse. So if you have like a chronic pain condition and you're very, very stressed over something, that can amplify the pain from that condition. It's very, very well documented. And also, pain oftentimes doesn't just activate the parts of your brain that process the actual experience. So how much does that hurt? Where is that? What kind of pain is it? It also activates areas that are involved in emotion. Like, so it helps you process the unpleasantness, the willingness to not want to be in pain anymore. So whether it's scratch that itch or it's ice that foot, something that you know you can do to relieve that pain from you. So that's motivation to escape from pain and the unpleasantness associated with pain. And then those emotional unpleasantness circuits are also involved in like emotional pain as well. So it kind of like overlaps in that way where it's similar brain areas being used to process these feelings.
Got you. Interesting.
So in your wildest dreams of all the success that you hope or think could be achieved in your research, what does that look like? Like in 200 years from now, we've made all the advancements that you think may be possible particularly in pain modulation management research, whatever that means for you. What does that society look like?
I think a society where we've learned, maybe not all, I don't think we're going to get there in 20 years, but many of the things that we want to learn from pain research, we would have good biomarkers for pain, so good ways to measure how much pain someone's feeling. We don't have a perfect way to do that right now. A lot of times it's from how much somebody reports they feel, which differs from person to person, how much pain you feel, even if it's the same exact experience. And two, then you have to communicate this to another person, your clinician, who then has to believe you. So it's like all these things that can impact that raw experience of how much pain there actually is. So one, finding a good way to measure pain. And then two, understanding exactly how the brain processes it, which cells are involved, which cells are not, and then like which ones could you turn off in ways that don't have all these bad side effects to reduce that pain. And then, or even we don't even go the brain route. Actually, let me not go into that. What would be the perfect feature of pain? And then a lot of chronic pain conditions too. So somebody might have fibromyalgia, somebody else might have chronic lower back pain, somebody else with chronic injury, somebody with a traumatic brain injury, someone else with a spinal cord injury. All of these have different etiologies or different causes. So the pain also might show up differently in the body or the brain. So is there a unified marker? Is there a unified thing across all these pain conditions that can be targeted to relieve pain in everybody? Or are we going to have to be as personalized as possible? Can we capture the brain cells that are important for pain in a particular individual? Be like, okay, all the brain cells that are important for pain, turn on. And then we capture all the ones that turned on. And then we figure out how to turn them off in that person, because it might be a different group of cells in a different person. Assuming those cells that are involved in pain remain involved in pain for the rest of your life. Sometimes cells trade jobs. Like it might be involved in pain right now, but maybe not later when that pain becomes chronic. Or maybe not later, even if it's the same exact pain stimulus, like you stub your toe, it might just activate different cells each time. There's some that are shared, there's some that are not. So the conversation gets very complicated. And the problem, that's why I'm saying, I don't know, 200 years, like I hope we can get there.
Yeah, you have a magic button that you push and everything that you think can happen with regards to your research and pain management comes true. In 200 years, magic button.
Well, if
we
that's
cheated
magic
physics,
button,
we cheated everything. So what is it? Is it like nobody feels pain anymore? Is it that we can control that? Like what you see what I'm saying? Like what's
magic,
like the pinnacle of where this could go at some point in the future?
I think that the goal is nobody feels chronic pain. So I think, like I mentioned, if you have a leg injury and it hurts, you got to stay off that leg for your healing. So we cannot turn off that kind of pain because that can increase all these other problems. It's unfortunate, but maybe we can do two things with the switch. One, we keep these shorter term, like acute injury type of pains, but then remove the unpleasantness and depressive feelings that come with them. And then we eliminate chronic pain.
Right, because chronic pain, even if it is the byproduct and like indicative of something structurally that's malfunctioning in the body, people have an added like emotional and mental side effect from the chronic pain, which can be like depression or whatever it is. Like I don't know, I guess what are some of the common mental side effects that are associated with chronic pain?
Before I answer that, actually, I'm going to take what I said back, because sometimes people ignore their pain. Chronic pain is defined as something that lasts for more than 3 months. Imagine you ignored it for 4 months. Like you might still need to address that condition, and the pain might be your only signal too. So I don't think that we should take away the pain and the chronic pain either, but maybe we just remove unpleasantness from all experiences of pain so that we can keep it as a teaching signal without any of the negative side effects like this emotional aspects, which I'll get into now. So people with pain can also come with symptoms of anxiety, depression, fear. So you can be afraid of experiencing more pain. You might move differently on that leg, or you might avoid situations that might exacerbate or make worse that pain, which can negatively affect your life. Because if you have a foot injury, anytime you walk, it can affect your pain. So all of these like what we call comorbid conditions also can impact your stress systems, which could then make pain worse, like I mentioned earlier, because stress makes pain worse. Then it can be this cycle where you're stressed and then you're feeling more pain, and then you're stressed about the pain, and then you're more stressed, So I think that, I guess if we had this like future sci-fi world where we could just solve pain in that way, maybe just remove all the unpleasantness from pain without actually removing this like very important signal that can help us, keep our bodies safe.
But what does that mean though? Because the unpleasantness with pain, at least from my experience, is the part that hurts.
And I think it's the part that teaches too. Like, I don't want to feel that again.
Because the experience of it being so negative, you like learn something from that.
Like touching the stove, like I don't want to do that again because that was a horrible experience.
Yeah, interesting.
And then it hurt for a while after too.
Mm-hmm. Mm-hmm.
So if you have an unpleasantness, so it's like, is that necessary for that teaching signal? Right. I mean, like I mentioned, the unpleasantness is also tied with the motivation to remove the pain. So maybe we don't want to get rid of the unpleasantness.
Maybe we don't want to mess up those circuits.
Maybe we teach kids from a young age, if you feel these feelings, even if they can't feel your pain, unpleasantness, you just teach them from a young age to
don't do it again.
Don't do that. Or like, if you feel this, even though it may not make you like mad, like you still feel that deep pressure and pain. I don't know. I've never had pain without unpleasantness, so I can't even imagine what it can be like. But actually, there's this famous clinical patient who I think he had a brain injury of some sort, and it pierced through an area of his brain called the amygdala, which is very important for emotion and other things. And he was not able to feel unpleasantness from pain. So doctors realized this a little bit later after treating him for a while. They were like, I think he had like some sort of like internal condition. I don't think it was appendicitis, but it was something this like internal pain thing that he wasn't reporting to them. And they found out about it and they're like, why didn't you tell us? He's like, I don't know. It just didn't seem important or something. Like they found it late because of the fact that he couldn't feel unpleasantness with it. And then they did follow-up testing on him. And all these tests made them realize like he can feel it, he can describe it, but it doesn't bother him. This is like one particular like clinical case.
Yeah, that's
his name is patient HM.
That's really interesting. So this makes me think like as an emergent phenomena, if we removed the unpleasantness associated with pain society-wide, could you see this making our entire society sort of shirk like overall conservative approaches, not just to politics, but like to everything? Because you're removing the unpleasantness, the fear, the hurt, and it could like offset. You see what I'm saying?
Yeah.
Like how psychologically, how would that change humans if we didn't experience that thing?
Yeah, like I feel like I'd always wanted to be like one of those people that does the thing with a knife in the fingers, like just because I feel like that's so bold and cool. But I just don't.
Like the cowboy game where you.
Yeah, but I just don't want to cut my fingers off. But like if that was publicly, and
you would have no fingers right now.
I probably have no fingers, but I would definitely be flexing it at every party. Like, yo, look at this thing I can do.
Yeah, so you'd be cooler if you didn't have pain.
Well, I feel like I don't know. Like I think I'm pretty cool now.
Interesting.
You don't think I'm cool?
Yeah. No. Yeah, bro. You're like you don't think? Yeah, bro. You're pretty cool. But yeah, it's Lindsay. It's super interesting because you studied the brain, right? And it's like when you niche down on anything, oftentimes you can lose sight of the bigger thing. And I just think that it's like interesting to think about the problem. Like as we solve problems, we sort of like accidentally create other problems that we like weren't aware that were like these emergent phenomena. And it just seems super interesting to think about how if we could remove pain, like how would society change? And I assume it could also change in like ways that are like positive that we have like no idea about.
Yeah, maybe I feel like we'd all be like Steve-O a little bit. Y'all remember Steve-O from back in the day? Steve-O, the dude from Jackass. He used to go and like hurt himself. It was that MTV show?
Yeah, Jackass.
Yeah,
I know what
he
Jackass
used to
is.
go hurt himself. You don't remember that, Lindsay, from like back in the day? That's probably like 15, 20 years ago. Steve, he
Yeah,
would
that
just
was a
be
long
hurting
time
himself
ago.
all the time on camera for the clout, kind of.
Yeah, that's what they did in Jackass. That's what
Yeah.
they all did.
Yeah, it was a bunch of them, but I feel like he was the chief.
Well, the only reason that is entertaining to watch is because you know what pain feels like.
Yeah.
So I do not agree
kinda like,
that society that we would all just be like that.
Interesting.
But isn't it interesting that people liked that though? Like, we know what pain feels like, and we know we don't like it. So why do we like watching other people feel it? Like, is that?
But we do like that though. You know, like even like socially, I feel like we really like people like reality TV show. They like to see people get like humiliated. We always love it as a people. We love it when a politician gets caught, like, you know, proverbially with their pants down, or like doing something wrong, embarrassing, and sort of getting the onslaught from the mat. Like, we do like to see that.
Yeah.
Is that because we feel pain that we enjoy that?
I mean, I guess there's the mirror neurons at play, but then there's also, I think, this othering that happens with people like that. Like, oh, this kind of guy is the type of person that decided to be on reality TV. Like, what a joke. Like this, you know what I mean? Like, you kind of don't feel the empathy, or at least in my experience, I'm like, I kind of don't feel like the humanness. Like, even when, like, if it's like a reality show and it's like a brother and he's going through something, I'm like, dang, I kind of don't want to watch this guy like go through this, you know?
No, I have no idea what you're talking about. What do you think, Lindsay?
I like watching people that I don't like on reality TV experience negative consequences.
Why do you think that is though? Like, why do you think that is that's like so enjoyable?
I think that it can be biological, but also social. I think that we've been socialized to want to see justice, to want to sometimes to want to see bad things happen to bad people. And I think that can be inherently problematic as well. I mean, when it comes to something petty like being embarrassed or dumped on a reality show, all the way to the most serious consequence, like the death penalty. Like, the idea of wanting to see someone else suffer because we think they did something wrong. I don't know where in the brain, like, our empathy shuts off and now we want the person to feel harm. It's kind of like, I'm not, it's like a lot of times I think, oh, I'm very like biological as a neuroscientist and not necessarily like psychology, which I'm sure a psychology human behavior expert would have a lot more to say about, like, why our inner bullies just, I don't know, is it cathartic for us? Do we feel like it's healing? Do we feel like there's this temporary satisfaction that comes from that? And then the question is why? And is that social, or is that something that's evolutionary? These are all like pretty interesting questions.
Yeah, super interesting. And like, if we didn't feel pain, it wasn't unpleasant to us, and we knew that the same was also true for other people, it would not be enjoyable for us to watch other people experiencing pain because they wouldn't be experiencing it.
But maybe it'd be enjoyable to watch other people take risks that are associated with experiencing pain, you know? Like, I enjoy
those risks ourselves at that point.
Wait, sorry, say it again, Lindsay.
I'm sorry. We could also take those risks ourselves at that point, but please, what do you enjoy?
I think that's true, but I think you can still be inspired by someone doing something that you're still capable of doing.
But like, you didn't, but like, it's the fear of the risk is a risk because it's like associated with the fear of something bad. The bad thing is some pain that you'll feel, even if it's completely social, even if it's like, you know, people will make fun of you. But if you don't have that, why is it even inspire me to what? I don't care if I get embarrassed. If I go on TV, I'm not going to feel pain. If everybody is like hate tweeting me, you know what I'm saying, and sending me death threats.
So if there's no perception of pain, then there's no inspiration derived from watching other people overcome the pain associated with the thing. Is that what you're suggesting?
Like maybe, you know, like, I don't know. Oh, it's so interesting because, you know, in this conversation, sort of in real time, I'm just realizing how impactful and like influential pain is. Yeah.
And
so interesting.
And I'm also noticing us kind of conflating emotional and physical pain because they have so many similarities as well. I think of them as separate a lot, mostly because that's my job. Like, I think about this a lot, like both emotional versus physical pain, and then when you have physical pain, the emotional side of it versus the physical side of it. But like, if we couldn't feel emotional pain, would we get you're right, would we even get satisfaction from watching other people not feel it? And also, like, I don't know if a lot of people would choose, if we could survey everyone right now, would you rather go the rest of your life without feeling any emotional pain, or do you think that like you wouldn't get rid of that feeling?
Yeah. So I actually have like a little anecdote about that. We've talked a lot about mental health on this show, and I have like battled with depression at various times in my life. And many years ago, maybe like 6 years ago, something like that, I actually was on Lexapro, an antidepressant, SSRI. And I remember when I took it, it takes like a couple weeks, maybe like a month or two to ramp up in your system. And once I had reached that point, I was like not bothered about things that otherwise maybe would have given me like anxiety or made me feel bad. Like if I remember I was taking physics classes in college at the time, and when I like did poorly on a test, I was like not bothered by it. It didn't bother me. I wasn't I just wasn't really feeling negative emotions that much. Right.
Stoic.
And I realized at that time, and I'm glad you pointed out, and you're like keeping track of the conversation, Lindsay, that I'm like conflating emotional pain, social pain, physical pain under this umbrella. Me not being a pain researcher, but I remember thinking that this actually feels great, and this would be great if I didn't like want to do anything with my life, and I didn't have these goals to, for example, become an astrophysicist. But I knew that feeling like that, I was never going to be motivated and driven enough to reach my goals. Cause like I think I got like a D on a differential equations exam, and I was like not bothered by it. I felt okay. And so I ended up, talking to my doctor, whatever, and getting off of it because I didn't want to like have that in that complacency. And but I do remember that lack of really having lots of, I guess it's, it wasn't physical pain necessarily, but really interesting. I never thought about that from like a pain angle.
That's interesting. I have this grad school friend who, I mean, he claims it. I believe him, but he's like claimed to have solved happiness. So he used to do a lot.
Oh God, he should let us know about that.
Do a TED Talk too.
It's like thousands of years humans have been looking for this answer.
He solved happiness for everybody, for every human
across time.
Well, he's at least solved it for himself. So he says that he feels content and happy 95% of the time. And
that's an insane hit
That's
rate.
crazy. This guy's next level.
He got to figure it out.
This person is also currently getting a PhD in neuroscience, so has been able to pursue many of these goals. But watching their behavior is really interesting because they'll do things like, they'll be in like stressful meetings, and maybe they'll receive like negative feedback, or they're anticipating negative feedback. So he'll instead just be like, yeah, I know you're going to say this, and this negative thing about me, talking to like professors and like people that I haven't personally, I don't know. It's like our first year. Like, I'm so scared. He's just like, yeah, no, like I understand that I did this, and this wrong. I understand I'm going to work on that. And then I'm also going to do this, and this. So let's move on now. And it's like, or he'll like, yeah, I'm just going to come to lab at like 12, 1 o'clock every day. I don't really care. Cause he's not like afraid. Like, I don't know, it's the fear that gets me up early every day. Like, I mean, I'm sure he's in an environment that is like letting people work whenever they want, but there's also like are my peers going to judge me? Like these things that would like make me act in different ways, that he's just like, like it's okay. So, and then you can also see that like, so it's nice because he like experiences a lot of happiness throughout the day, every day, and very, very few things. I've never seen him upset about anything. Like it's interesting. It's so strange with that, but it's also like sometimes I do want to feel upset because I feel like that'll motivate me to like
do better.
Motivator. And he's still a high achiever, but it's also like sometimes I'm like, why did you make a decision? It's probably just because he's not afraid of negative emotions of the consequences.
Lindsay, he sounds like a generational philosopher. To be motivated and he anticipates everything before it happens, and he's cool about the outcome. What a guy. What a guy.
He's an interesting guy. It's fun going to grad school. You get to meet people who are just so strange, so interesting. Lots to learn from.
Yeah, I think that's one of my favorite things about the kind of the science, the SciComm community, and even like the STEM community in general is like it's a lot of there's no NPCs in our community, man. It's like it's a cast of characters for sure.
Yeah. Okay, so let's switch up gears slightly. I cannot have a conversation with a neuroscientist and not get into free will discussions.
Okay, let's do it.
Let's do it. So I think I'd like to hear your thoughts on free will as somebody who studies the brain, as somebody who understands, pain and what neurons can do and can't do. How do you feel about free will?
Do you mean like if we have free will?
Yeah, I guess in terms of it existing or not, or to what extent.
Let's first define free will.
Let's do that.
Can you?
Go ahead. You go ahead.
I should. I mean, my interpretation of the definition of free will is that we make decisions that rule our life, and those decisions are made independently, as in like they come from us, and that we have the power to do that. Is that what you would say free will is?
Yeah, well, let's see. Come from us. I guess what it would mean is that you truly are making decisions for yourself that are unaffected by any sort of deterministic process.
Yeah, and that's pretty aligned with the definition on Google here. The power of acting without the constraint of necessity or fate, or the ability to act at one's own discretion.
Right. So I guess, to a quick little heuristic example, if my brain is wired in a specific way and my neurons have, respond to different chemicals, like dominoes that are being knocked over, I could be in a situation and things are happening in my brain that are going to deterministically lead to me doing a certain thing or thinking a certain thing. Whereas if I really have free will in the way that I think people tend to think about it, I'm sort of actually in my mind playing out all the scenarios and making a choice that could always have been different. I don't know if that like makes sense, but that's kind of the difference of having it versus not having it that I think of.
So I think that the Google definition where it said we make decisions without the constraints of necessity and fate, those are two very different things. So can we make decisions, and are there brain types that make decisions without the constraints of necessity? I think if you are not in a state where your brain, because there's lots of, when you are in a high need state, so your brain really needs sleep right now, or it really needs food, it will transfer a lot of its resources to make you motivated to get that thing, because you're evolutionarily, you need that to like keep going. So, I mean, for example, there's studies about how people who are very hungry, or we've even solved the brain circuits for these in mice, like when you're very, very hungry, that can impact the amount of pain you might feel in that particular moment, because your body is like, we don't need to worry about your pain right now. We need to worry about getting you some food so that you can give energy to your brain. Or if you're very, very sleepy, might you make different decisions than when you're not. So I think that your need state, and then of course, like people have different socioeconomic statuses. So there's people who might make decisions based to prioritize their needs more often than others. And then it's a question there of like, yeah, could they have made a different decision in that moment? Like maybe if somebody wants to, I don't know, steal food, which we can talk about the ethics of, if you need food and you don't have any money, like, is it really that wrong to steal food? But like the free will in that moment, I think could be determined by your brain's need state. But I think that it's not necessarily like 0, 1, or like 100%. I think it's probabilistic. So maybe you're more likely to prioritize your need state if you're in a situation where you need to prioritize a particular necessity, and that might change the probability of making a particular decision, because those drives are very strong. Like if you're hungry enough, there's a lot of people who do anything to get some food.
Yeah, that, I mean, everything, all of these different like need states that you're talking about just sounds like, to me, complete determinism.
Yeah, constraints on freedom. Like, yeah, you can't.
Like when you're hungry, the probability of you making a certain decision changes because because that's a thing that's happening in your brain. That's not a thing that you did. That's like that's something happened in your brain.
It's an externally, I guess, and internally imposed constraint that kind of inhibits your ability to act freely, or at least with a wide variety of choices.
So then the question is that person to blame for what decisions they make if they're in this high need state?
If they're in like a primal and an almost instinctual state. Like, I don't know if you all have ever read the book Man's Search for Meaning. I think we might have talked about it. It was about this guy who survived being in a concentration camp. I think that was what it's called, Man's Search for Meaning. And he basically described this experience of starving, like during that time period, and how he literally couldn't think about anything but the next piece of bread that he was going to get. And like that was like, he remembered being in such a primitive state where that was the only thing he could think about for many days on end. Like, when is my next piece of bread coming? How I was going to feel when I taste it. And then but like this idea that he knew he was going to write about these experiences one day, like allowed him to survive throughout that experience. But yeah, it's kind of hard to say, like, if a person,
I would say no, though. I mean,
no to what?
Me, okay, so like in physics, when you really want to test out a theory, what you want to do is you want to look at it at the extremes. Like, if we really, really understand gravity, let's look at the most extreme gravitational source that we know of, the center of a black hole. Well, we actually don't understand everything about gravity because we have no idea what happens at the extreme. And in something like this, starving to death, this is like at the extreme of what the human brain goes through. And in that case, it sounds like, if I'm synthesizing what you were saying, that this person is not necessarily under any sort of free will. Their brain is only having thoughts of, where are we going to get the next food? How are we going to get this next piece of energy? And so I would say, I guess one way to interpret that maybe is that the free will that you have fluctuates, but I would say that we just have looked at an edge case, and the only reason it seems like you have more free will when you are less need constricted is because there's so many more things in that, so many more variables in that equation, that the answer, the deterministic answer, is not one that is like easy to thumb through or predict. And we're calling that free will because there's so many possibilities, and it feels like that's like how I would think about it. But I don't believe in free will, though.
Yeah, but I kind of can't. Well, at least I'd be curious about your perspective, Lindsay. I don't feel like I can argue against that. It almost feels like multimodal will, like, instead of free will. It's just like so many different options for things that we can do that it's kind of, like you said, it's kind of hard to predict it with certainty. And so that make it free?
But it gets easier when the need gets tighter.
Right.
Yeah.
So it's like you're probing a model in a very restricted regime, and it works better there because you've like zeroed out a bunch of coefficients on certain terms.
I need to pause. My computer's about to die, so I'm going to run and get a charger. I'm so sorry.
Okay.
Okay.
Yeah, no problem.
No worries.
No problem. Yeah, that's super interesting.
Yeah.
That's super interesting. I think that, no matter what I hear, it just doesn't make sense that we are having like free will. It just seems like it's like an equation that is too complicated
complex for us to
such that it feels like, or that it seems like people are having free will.
I mean, something that's interesting to me is that one of the potential promises of advancements with quantum computing is us being able to run much better simulations. And like this idea that maybe one day we'll be able to reduce the complexity, or like we not reduce the complexity, but calculate or more accurately triangulate the complexity.
Yeah. Imagine that paper when quantum computing is a thing, and like machine learning has been able to be applied using that sort of computing resource. And imagine that paper that comes out that proves, well, one way or another, deterministic or conclusively, that we do or don't, in like to mathematical certainty. Where you can predict. This sort of feels like those like a sci-fi where there's this like all-knowing, all-seeing machine that literally knows exactly what everybody is going to always do at all times. Sort of maybe like something from the Matrix. Yeah, really interesting.
Which actually had me thinking about another thing with the Matrix. That I don't know if you remember this, but the first iteration of the Matrix, they said it was like this paradise, and no one felt pain. Like everyone felt joy and pleasure, and in the science fiction, like the people in that generation of the Matrix rejected it because it didn't feel real. Like their brains knew something was wrong. Because they weren't experiencing this pain.
That's super interesting.
Yeah. Lindsay, one of the things we kind of talked about right before you left is this idea of doing advanced simulations with quantum computers, and like perhaps being able to decipher the complexity of this multimodal or multifaceted will that we have in a way that allows us to be more predictive. It's fascinating stuff. But were you about to say something?
I was going to talk about another constraint that could impact decisions. Is like, when I was walking and coming back, I thought about racism or any bigotry, right? A brain that has been socialized and taught through years and years of learning that a particular group of people should be feared, not trusted, and even harmed, is one that would be more likely to make decisions to harm that group of people. Like, in that case, that might also impact, I'm wondering if that impacts their free will as well. If you've learned your whole life to hate somebody or hate people that have a particular trait, when it comes time to make a decision, like in any social situation in the future, like, are your options constrained to this fear that your brain has built over time? Or even people who have childhood trauma, and you know how like that might impact your future relationships and things like that, impacting the way you process social situations, or the risks that you might take. Like, there's so many things that the young brain, or just like the developing brain, is so sensitive to, that might also impact future decisions. And it's like, we're growing our brains to be tuned to certain things, just depending on the environment you grew up in. So that people that grew up in an environment are like more similar to each other, but is it that their brains are structurally or processed similar to each other because of the things that their brains have been taught over time? Of course, there's genetics as well. So it's like, it doesn't make me have, that much more empathy for someone who hates me because of my skin color or because I'm a woman or whatever. But like, it makes me wonder.
What? If you could prove, like, just here as an example, if you could prove that somebody who at a young age went through a social learning or conditioning experience that genuinely restricted their range of decisions, as it pertains to I think that's a great example. Racism, as it pertains to treating a certain group of people, and you actually knew that their brain was not capable of making the types of decisions perhaps that we would make, or that somebody more open-minded would make, that had different experiences. If that is the case, how could you blame them? Like, how could that not? That's almost not their fault at all.
If we knew for a fact that they were never exposed to the opposite opinion, or any opposite examples that might lead them to not be racist, then I guess it's similar to like, can you blame a child for throwing a tantrum in a movie theater? It's like
it's a kid.
It's a kid.
I blame the parents.
The brain is only going to do a certain amount of things when it's upset, and it's done this thing, and we just got to deal with it. It's like, I'm not saying that. I'm not trying to like infantilize racists because but it is like, it's interesting to think about. Can you really?
It is. It's very.
But we're also talking about the extreme here when they've never been exposed to like any anti-racist thoughts. It's like, have they really never been exposed?
Right, but sorry, I didn't mean to cut you off.
Not been willing to listen to those perspectives, maybe because of the way that they've been taught. So it gets complicated.
But isn't your receptivity to new ideas also a function of what you've been exposed to, and maybe even a function of your genetics? Like maybe genetically, some people are like more willing to expose themselves to different ways of thinking or something like that. So like you can, just because somebody is confronted with a difference of opinion or something like opinion or belief or thought, doesn't mean that they're even like really able to. And you see that all the time. I know, because you make content online about neuroscience and you're a Black woman. So I know that you get messed up comments from people all the time. People who think that you don't know what you're talking about. Also because we're scientists, and there's people who think that scientists don't know what they're talking about for some reason.
The experts,
right? Yeah. And I don't know. It's really interesting the way that I guess human behavior in general is just interesting and mystifying.
I mean, it kind of feels like if I were to extrapolate the racism point that you made, Lindsay, and like kind of apply it to any other conditioning that we've had growing up, being civilized, like the very act of becoming civilized as a human imposes specific limitations on our free will, right? Because it like gives us a range of acceptable behaviors, unacceptable behaviors, things that will be punished for.
Yeah.
And so like that kind of creates these parameters. There's some people that may act outside of those parameters, but like not in every way, right? Like,
Yeah. So I guess I feel like you kind of skirted your answer to this question a little bit. Do you think, or for you, is it more of a blend in like in certain times, maybe you have more or less, but I do remember you saying it's like not a 0 or a 1. It's not all or nothing. And is that kind of where you land, that, people maybe have varying degrees of free will?
Yeah, I think it depends on the situation, depends on the person. It depends on the environment and then their genetics and their socialization. But I feel like,
yes, you sound like a scientist answering this question.
maybe I want to believe we have some, and then we haven't even gotten to the whole like spiritual fate aspect of it, which I don't know how much deeply I want to go into anyway, because how can you prove any of that? But like, I would say free will gets really messy. I'm not sure if we always, I don't think we always have it. Let me say that. I don't think we always have it.
So
I don't think everyone always has it.
So ethically, would you, and I'm just curious about your opinion on this, with that belief, ethically, do you think that the degree to which people should be held responsible for their behavior, good or bad, should depend on the amount of free will that they had in the moment when the thing happened?
Only if we were able to reliably measure the amount of free will they had.
Okay, so if you could prove that number, like if you could actually reliably
index of freedom. Yeah. We could extrapolate Lindsay's index of freedom, and somehow apply that to every case-by-case situation. That might give us.
Sorry, officer, I only had 4% free will at the time. You're gonna have to let me go.
I can prove it. Yeah, I wasn't free to make that decision.
I skipped breakfast. I was really hungry this morning.
Super hungry, officer. There's no way you can rest me.
Or I was on drugs.
There you go.
Yeah.
It's also like I was also so stressed that I had to consume alcohol because of all my like. But then it's
none of this is my fault. All these things happened to me. Like I was stressed out, so like I had to drink, and then I got in the car, started driving.
Here are the equations too, by the way. Here are my papers.
I can mathematically prove that this is not my fault, officer.
Yeah.
Then I mean, I guess before we can prove that, I guess it's just like safer to give everyone the same rules for the society to run smoothly.
And
I think if you're going to give everyone the same rules, you should give everyone the same resources so that they're not driven by these high need states that might affect their behavior.
Yeah.
Then it's like a catch-22. Like is that what catastrophic is? It's like you haven't given everyone the same chance to make sound decisions, but then you judge everyone on the same decisions that they do make. It's like
some people have like more limitations and restrictions imposed upon their free will due to lack of resources, in theory, right? Therefore, why should they be subject to the same rules if they don't have the same resources? Dang, that's powerful.
Yeah. It's like a systems thinking, like a systems approach is that, and that's what a lot of the like equity talk is about, right? It's like certain people have less opportunities to do certain things. Obviously, they're going to make a different set of decisions, or they're not going to have the same opportunities. And you want everybody to have you want it to be fair so that everybody has. And so, yeah, that's pretty cool. This free will conversation is sort of like another way to just look at the opportunities that people have in society.
Yeah, it's fascinating stuff.
Definitely.
One of the other things that we talked about, switching gears a little bit here, Lindsay, we talked about this idea of maybe some degree of dimorphism in a pain response. Was that some part of your research as well?
Do you mean like sex differences?
Like a sexual dimorphism, right?
Yeah. There are, like I mentioned, we might turn off a particular group of cells and that reduces pain in a particular mouse, or we might find that it only works in the males, or it only works in the female mice that we study. So there are particular circuits throughout the brain that are separate in that way. I mean, it's not all or none. Sometimes like there's going to be some overlap, but we do see that difference. And there also are broader effects of sex or gender on pain, where we see that females tend to have a higher sensitivity to pain and are more likely to develop chronic pain conditions. Did you have any other specific questions about?
No, that's so interesting. But that's specifically, those research findings are specifically in regards to female mice, or is that broader? Is that like humans too?
The circuits that I was mentioning, those like different brain circuit might contribute to pain. Those are in mice, but then the phenomenon of the increased pain sensitivity and the increased prevalence of chronic pain conditions has been found in humans as well.
And it's interesting because that almost sounds like counter to a common knowledge that, or like something that I think is colloquially said a lot, right? That women or like have a generally higher pain tolerance than men.
It can be socialized to think they do, because also women are socialized to, men are less socialized to like outwardly show their pain. So there's a lot of pressure. There can be a lot of pressure to hold it in, downplay it. And that might actually also impact the results that we see in the clinic, right? Are they really,
interesting?
If we're relying only on subjective reports of the amount of pain someone might feel, are those being impacted by their social conditioning as well? I think that when you do like basic sensory testing, where you don't ask them to respond, you just see like other measures like reflexes or other ways that they might show pain behaviors. I'm not 100% sure, but I think that those sex differences have also been shown when you don't rely on like their subjective reports. But like it does get interesting, because even the behavior someone might give might also be impacted by like the way they were socialized. Who knows?
Yeah. Is that so? Do you have a sense? Is that like just generally true with mammals, that male and females, all species of mammals, have different pain tolerance levels? I don't know. I guess I don't know the extent at which this would have been tested on like hippos or something.
Yeah. I mean, I'm not sure about all mammals. I mostly just look at mouse and humans.
Yeah.
Or rodents and humans. I know that like you don't always see the effect. So you might give a particular like compound to induce like inflammation in the paw. Like you might see, I think it might depend on the particular model. I'm not like a huge sex differences researcher, so I can't like get into the deep weeds of it. But I do know that it's not like it's not all or nothing. Like it's not guaranteed that I'm going to see the females have less or have more pain every time I do any pain model.
Would there be a difference at all from an evolutionary perspective?
Why would there be a difference?
Yeah. I get like if I, I would think that it would just make sense that it was equal, right? Like both males and females of males and female mice, I would think that they would benefit the same from having similar pain sensitivity. I guess like from an evolutionary perspective, is there a sense for why that would be different? If it is, which you said, I think you brought up a really good point about like human men being incentivized to act like things don't hurt, right? Which I think is a really sort of a great solution for why there may be a large difference I don't know how big it is, but a large difference in humans. But like if there was one, like why might that be the case?
Because I cannot logically think of why it might be evolutionarily beneficial for there to be a difference between the sexes. Yeah. I wonder if it's one of those things that have just evolved because that's what happened and not because it was like to serve a particular goal, because evolution is not always goal directed. So sometimes we have traits that like are just unfortunate and didn't get selected out just because they didn't, and that's where we are with it. So maybe it's that, but I'm not sure. I would have to talk to maybe more of like an evolutionary biologist or something to get more in depth with it. I'm not really sure why there would be a benefit to having different pain sensitivities when, again, pain is protected for everyone.
Right. Yeah, I mean that makes sense. Is there anything else that you want to share? Or is there like any topics that you feel like are interesting to talk about, or that you would want more people to know or be aware of?
I mean, obviously I think a lot about pain. I think a lot about pain in the clinic too. A lot of people are not believed about their pain. A lot of people have told that their pain is in their heads. And we've spoken a lot right now about how the brain, well, we didn't even get into the placebo stuff. We should talk about that.
Yeah, let's talk about that.
Yeah,
is the placebo effect real?
Yeah, I mean, so the placebo effect is real and it's established, and we've seen it in animals and humans, at least when it comes to pain. I think I've read that the placebo effect in pain is one of the strongest ones in the body, because your experience of pain is consciously perceived by the brain and can also be modulated by the brain. So the placebo effect is this experience where expectation, in this case of pain relief, would actually lead to you feeling less pain. And we've found the mechanism for this, where when you expect pain relief, you can actually your body will release natural compounds to relieve your pain, many of which are these natural opioids. So you might know of opioid drugs like morphine, heroin, things like that, fentanyl. Your brain also makes natural, these are called endogenous opioids, to relieve your pain, some of which might include things like endorphins or enkephalins and things like that. So in these situations where you expect pain relief, your brain can trigger the release of these natural opioid chemicals to relieve pain. And unfortunately, it's temporary. It doesn't happen reliably. So it might not happen every single time you want it to. And some people don't experience it. Other people do experience it. There's been a search for whether there's a sexual dimorphism in this too. Like, are males more or less likely? And I think that's still up in the air. But because the way you experience pain, and then the opposite is true as well. Like, expecting more pain can impact the amount of pain you perceive in that moment. So if you like are getting a shot and you're like really nervous about it, and you're like really tense and you're really stressed about it, that can actually cause you to feel more pain in that moment through a release of different compounds that can actually amplify your pain. Like I mentioned earlier, stress and expectation, things like that. All of these things can impact the amount of pain you feel. And it's not just as simple as how many pain cells in your skin or in your organs are sending information up to the brain. It's like all these little things that can change the amount of pain you feel. And that's why I think pain is so interesting, so cool. I mean, of course, it's like very unfortunate for a lot of people. But just the idea.
Yeah, you sound like a bit of a masochist.
I don't think it's good. I just think it's interesting because it can be changed and modulated so much. I mean, imagine you stub your toe. Imagine you stub your toe and then like wherever you guys are right now, you see a gorilla. I'm sure you're not going to be worried about your toe because you're going to be like, gorilla. Like your attention can also shift away from your pain, which can affect how much pain you feel in that moment. So I just think that like the experience is so dependent on your particular state at the time, how much stress you're under, again, expectation. You can hypnotize people to feel less pain. People with chronic pain can respond and do respond very positively to not medical treatments, but often respond very positively to cognitive behavioral therapy or something called pain reprocessing therapy. Pain reprocessing therapy, which is this way, I think his name is Dr. John Sarno. He created this therapy program to teach people to remove the fear from their pain. So kind of decouple all these negative fear and like emotions that come with it. And that can actually reduce the amount of pain that they might perceive in the moment or reduce the impact that chronic pain has in their lives. And it's like they didn't take any drugs. It was just like talk therapy. Often people think that talk therapy doesn't work, but actually it really can. I'm not saying it will. I just think it can. So like, and I think in their early studies, they found it helped about 85% of people. I'm not sure exactly the metric of how much it helped, but it was significant enough to like make an impact on their lives. But
yeah, I've always been a really big mindset person, like mindset and attitude. And I think that, in my opinion, one of the most remarkable discoveries in modern science is like the placebo effect, that when you think differently about your experience with something like pain, whether you're feeling a lot of it or you're not, that actually has a measurable impact on things. And that almost sounds very unscientific to me. Like that's one of those things that to me, that's like one of these unscientific beliefs that I have. Justin and I talk about this sometimes. We try to ground the things that we believe in science, but we also have unscientific beliefs in like the fact that you can just change your attitude and then change, your outcomes is something that feels to me very unscientific. But like with the placebo effect, this is actually a real thing. And it kind of sounds like magic.
It does. Magic with the mechanism. I think it would be truly magic if it was something that was like, if you just will it hard enough, it will happen. Like, it's not like that. Like I said, there's going to be differences with different people.
Right.
And you might not be able to activate this particular system all the time. You also can't really like do it at will. Like your brain has done it for you, but you can't just be like, do it this time, but don't do it this other time. Like it's one of those things that just happens. So it's interesting because we can, in the lab, investigate the circuits that are involved in the placebo effect and see if that's something that we can help target and turn on later. So earlier we were like talking a lot about turning off cells. What if we could turn on the quote unquote placebo cells to get this natural pain relief through this natural opioid system without side effects? I mean, that'd be a really cool eventual goal, because again, when you take an opioid drug or many drugs, if you take it IV or systemically, like or through a pill or whatever, it goes all over your body. It's going to attack, or it's like these opioids molecules are going to be floating around looking for anyone who can bind to them, any cell who has sensors for them. And those opioid sensing cells are present not only in brain circuits that are involved in pain, but also brain circuits involved in reward. Like I mentioned, things like addiction, cells that help you breathe. A lot of times, a lot of the reason that opioid overdoses lead to death is because these opioid molecules bind to your muscles that help you breathe. So like I said, I think I mentioned earlier, opioids shut cells off. So it shuts these muscle cells off, and then you literally can't physically breathe because you've taken this thing that will attach to them, and just by just attaches to what it sees. Or even there's opioid sensors in your gut. So people who take opioids might report constipation. That's because the cells that help your gut contract and keep pushing things through also shut down. So it's
Yeah.
huge.
I remember I was taking painkillers after I've had several knee surgeries, and one of the side effects when I was taking, I don't know if it was Oxycontin or Percocets or something like that, but yeah, I was constipated while I was on them. I didn't poop for days.
Man, thank you for that information, Dakotah.
I really wanted to though.
Yeah,
bro.
It wasn't coming out.
It just wasn't coming out.
Dude, I remember I had to take Percocet after my wisdom teeth. One of the worst painful experiences I've ever experienced.
The wisdom teeth? I also had that, but I told myself that it wasn't going to hurt.
So just a quick anecdote here, actually. Fun fact about my wisdom teeth removal. I woke up in the middle of I was anesthetized, and I woke up in the middle of the anesthesia to the doctor like having his lab coat off and everything was off, and he's like ripping at my tooth. I come back the next week.
He was butt naked?
No, he wasn't butt naked in the room. He was just like he was hot. He was burning up. So he just had his shirt on. So the next week
you looked at him, he was like, bro, it's
hot.
Yeah, I was cooked, man. I was so drugged up. But I came back the next week and they were like, "Oh, you're Justin, you're the guy." They were like, we had such you broke the doctor's tools with your teeth. It was so hard to remove them.
So the only reason those masculine wisdom teeth.
Yeah, man. So the only reason I experienced so much pain was because he had to literally break several tools to get my teeth out. So
yeah, bro, you're a liar.
No, seriously. I mean, there's pictures. We can actually roll the clip and show a photo of this. My jaw was like this big for my wisdom teeth. There's no cap in my rap. And when I took those Percocets, I was sending everybody videos, like happy videos. It was a good time.
That's pretty funny. That's crazy.
Don't do drugs though, kids. That's not. Yeah, I'm saying that is for pain relief specifically.
Definitely.
Yeah. I mean, there's so many harmful side effects that we want to steer away from prescribing opioids. We definitely want that. So that's why this natural endogenous opioid system approach might be cool, because if you can get this release to relieve pain in only a particular set of small brain circuits and get the same effect as you have gotten from giving this drug throughout your whole body, that would be super ideal.
Yeah. No, exciting implications, Lindsay. We are here at like an hour and a half now. We really appreciate you tapping in with us, and I think we had a wonderful episode, and we certainly appreciate your insights. Is there anything that you want to leave our audience with, maybe an inspiring thought from your research or an inspiring concept?
I think I would just say that if you've been told that your pain is not real, if you experience pain and you've been doubted and you know it's real, and if people told you, oh, it's in your head, I like to think of pain like this. Pain is an experience that is generated by your brain, like many other experiences that you have in your everyday life. But that doesn't mean it is not real, even if it is only in your brain. So there's a lot of people who have chronic pain that we can't find any evidence of that pain in the body anywhere, but they still report feeling so awful. And then doctors are like, oh, it's in your head. If your doctor says, or your clinician says it's in your head, we're not going to worry about it. Don't listen to that person, because even if it is quote unquote only generated by your brain, it is still a real experience. Your brain is making real experiences for you every day, and it needs to be addressed, even if we address that by approaching it from a brain-based perspective. So maybe consider different brain-based therapies like cognitive behavioral therapy, pain processing therapy, mindfulness meditation, other things like that, as well as considering other things like physical therapy or maybe particular medications for a holistic approach to helping you with your pain. Because though, unfortunately, there is no particular cure for pain, many people find relief from utilizing multiple approaches within this pain relief catalog that we have for people. And there is a hope for pain relief in your future, and I'm rooting for you.
Awesome. That's a great last message. It's been great talking to you, Lindsay. We've been connected online for like a couple years now. Always love dipping into a little bit of neuroscience, and you are the first neuroscientist that we've had on, and definitely the first pain researcher. Do you want to share with people where they can follow you? You make lots of great content online.
You can follow me at neuro_melody on across platforms. So Instagram, TikTok, Threads, Blue Sky, all these things. I also have my website, lindsay.ejoh.com. And also I'm on Substack, so I'm writing blogs on there if you prefer a written format. But yeah, that's where you can follow me. And I make content teaching people about the brain, teaching people about pain, and just demystifying the process of getting your PhD in neuroscience, bringing people throughout my journey as a PhD student and beyond, because I'm graduating by the end of this year. So
congratulations.
Follow my journey.
All right. Sounds great. Thank you again, Lindsay. And this has been another episode of Curiosity Theory. As always, everybody, stay curious.
Peace.